Hey guys, so we're going to talk about partial fractions today, okay? Now, somebody asked me to do this, and the first reaction I had to that was gross. Because the process of doing it, what I remember, was just very unpleasant. But it really is a straightforward idea. It's very clever how they do it, and it really gets into some fundamental ideas that you actually don't really get deep into until much later in mathematics, okay? So it's a really great technique, and let's get into it, okay? So, alright. So, alright, we have the following situation, okay? Well, let's just have a little refresher, okay? We're familiar with how to integrate something like 1 over x minus 2 dx, okay? That's no big deal, right? All you have to do is say x minus 2 equals u. You then set dx equal to du. This turns into 1 over u du. Oh, I know how to do that. That's really easy. That's just natural log of u. And then this equals, and then we just basically substitute this u back in, this x minus 2 back in for u, and we get natural log of x minus 2. Okay, that's great, but it's limited. It's limited. That does not, this is good for something simple like this, but what if we had to integrate a function like 2x minus 5, x minus 1, x minus 4. Okay, let's say we had this guy. What would happen there? Because this is just much more complicated. I try to do the same trick of u substitution. I say like, okay, let's set x minus 1 is equal to u. What happens to all this stuff here? Well, that doesn't get any simpler, okay? This would just turn into, this would be 2, let's see, this looks like 2u minus 3 over u, and then u minus 2. So that doesn't help at all, okay? That's just as difficult, at least as far as I can see. So we need some other way of approaching this problem. How can we approach it, okay? Well, one thing that'd be great is, how about I just take a look at what this thing is like? Okay, let's just see what this thing looks like here. If I graph it. So let's see. This guy, when I'm at 1, this guy has a horizontal asymptote. When I am at 2.5, at like 2.5, I go through 0. Okay? And when I am at when I'm at 4, I have another asymptote. Okay? Notice that 2.5 is actually equally between 1 and 4. Just fun fact, I guess. Fun fact. So, what should we do here? Okay, so what does it look like? Well, I can tell you that it looks like the following. It's flat over here, goes down to negative values, it's positive, passes through 0, as we said, shoots to negative infinity, and then it dies out like this. Okay? So that's the basic pattern. Now, again, I don't know what to do with that, just looking at it. Okay, I'm not sure. So how about we shift this around a bit, okay? How about I write this, how about I just look at what these guys look like, okay? How about we have a graph for 1 over x minus 1. That'll just be this. And let's have a graph for 1 over x minus 4. So that's just going to look like this. Okay? Same thing, just a little farther out. Okay? Okay. So, what's going on here? Alright? What can we sort of learn from looking at this and comparing it to that? Well, one thing that I sort of notice is that this guy has an asymptote, right where this guy does. This guy has an asymptote right there. If I just added these guys to each other, I get this right here, right? It's flat, like here, and both of these are flat, so they both turn something flat over there. They're both flat over here, like over here and there, so it'll be flat over here, and they have the same spikes. So what if I just add these guys together? What do I get? So let's try that. We have to switch to the red. Sorry, guys. So, I do this. 1 over x minus 1 plus 1 over x minus 4. Okay? So, how do I add these guys together? Well, they have different denominators, so that's sort of awkward to add the, as they stand. I want them to have sort of the same denominators because that's like the same unit of measurement. It'd be sort of like adding them up together now is like adding up feet and inches or miles and rods or something like that. Like that's just, you want the same unit of measurement. So let's get the same one. So let's see, this is going to be, we do that by, we get that same common denominator by multiplying basically what they don't have. So x minus 4 times x minus 4 under there. Then I do x minus 1, x minus 1 onto x minus 4. Alright, same common denominator. That means we can add up the numerators directly. I get, when I add up those numerators, 2x minus 5 over x minus 1, x minus 4. You guys see that? Because x, that turns into 2x, minus 4, minus 1, that's minus 5. And oh boy, congratulations, there we go! That's exactly what we were looking for right there. This 2x minus 5, x minus 1, x minus 4. So what's valuable about the fact we broke this up? Why do we care about all of that? About all that rewriting? Well, the reason why we care is, the whole reason I'm sort of looking at this problem is I'm interested in, okay, how do you integrate this? How do you integrate this guy? Well, as it turns out, this guy is the same as these guys, and oh boy, I know how to integrate these guys. It's just that, right? It would just be two separate u substitutions for the two different integrals I could cut up there. So there we go. And we just get, after a little bit of work, natural log of x minus 1 minus natural log of x minus 4. Okay, so this is great. In this one situation, it turned out really well. Obviously, we were able to break up this guy into two things we could integrate. Okay? So, alright, that's nice, but life isn't so simple. This one just happens to be like one of this, as in there's a 1 up here, so there's 1x minus 1 and then a 1x minus 4. But what if this had been more complicated? What if this had been something like 4x minus 8 over x minus 1, x minus 4? What if I wanted to integrate this guy? What would have... I don't know what two guys would add up to make that, okay? I'm not clear at all. I have some sense that it would look sort of like this, that it would look again like, oh, okay, I add these up in some fashion. I can do that actually. I can say that, okay, I want this guy to somehow equal x minus 1 plus x minus 4, but maybe instead of 1's up here, I have an A and a B. Now why do I have it like this? Because I have a strong feeling that this guy right here is made up of these guys, just like this guy was made up of these guys. But just in different ratios, okay? Instead of maybe 1 and 1, it'll be 2 and 3, or 4 and 8, or something. Okay? So, and again, the reason why I have this feeling is if I were to draw this guy, he'd look an awful lot like this, where he has the same asymptotes as these two guys, and he decays in the same way, right? He goes to 0 in this direction and in that direction. Okay? So, what can we do with this? Where can we go with this? Well, okay, if this is the form I'm looking for to see how much of these guys makes up this guy. then I guess all I really need to do here is just like, okay, let's just do what I did there. Let's give them the same common denominator. So that turns into ax minus 4, x minus 1, x minus 4, plus b x minus 1. Okay. And let's see, then we rewrite this. How about instead of having all the a's together here, how about I get all the x's together? So let's do it like a plus b times x, and then I have plus, let's see, I'm going to have negative 4a minus b. Okay, so this is nice. This is cool. Now, why is this a good form here? Why do we care? Because the idea is I want to figure out what the right amount of a and b are. Okay, that's the goal. What do I have here? Basically, if I add these guys together, then it says that okay, a plus b gives me a certain amount of x. And negative 4a minus b gives me a certain amount of the constant, okay? Let's see, how much x do I have? I have 4x. So if I want these two sides to equal, right, then 4 should equal a plus b, right? 4, I have x's, and that's the amount they come in. And I should also have that, oh, well, I have negative 8 constants there. This should turn into, this should be negative 8 right here, all of that. Okay, so I figured out by sort of figuring out, okay, these are the ingredients of this guy, but I don't know how much of the ingredients I want. By getting the same common denominator and sort of rewriting it, I see, oh, well, this is how much a plus b I need. A plus b gives me the right amount of x, and this amount gives me the right amount of the constant. Okay, so what do I do with this? I do some algebra to solve these two guys together. Okay, so how do I go about that? How do I go about solving that algebra right there? This looks like 4 equals a plus b, and I have a negative 8 equals negative 4 plus b, or minus b, excuse me. Please write that, minus 4a minus b. Okay, so, alright, what can I do with this? Let's see, well I have 1b here, and I have a minus b there, so how about I add this equation to that one, okay? I'm going to add 4 to this, an a to that, and the b to that, okay? A plus b to this side. Alright, so what I'm going to do is negative 8 plus 4 equals negative 4a minus b, and then plus a plus b. Alright, we understand how we're able to do that, right? 4 is the same as a plus b, so adding 4 over here is the same as adding a plus b over here. Okay, they're the same amount. So what does this turn into? This turns into negative 4 equals negative 4a, and the b's cancel, excuse me, at negative 4, that'll be negative 3a. Okay, so, oh, well that's easy. A equals 4/3. Alright, now how can I use this? Well, let's just plug that into that equation right there. So 4 is equal to 4/3 plus b, which implies that b is equal to 4 minus 4/3, so that should be 8/3. So there's my solution right there. I have now figured out, oh, how much of x minus 1 do I need and how much of x minus 4? Well, I'm going to need a of these, which is in this case 4/3 of those, and I'm going to need 8/3 of these. Okay, so now if I want to integrate 4x minus 8 over x minus 1, x minus 4, all I have to do is just split it apart, as I've just done, with 4/3 of x minus 1. Integrate that part, and then integrate 8/3 of x minus 4. And again, just use substitutions, and I've got it, and I've got it. Okay? So, we have now an incredibly powerful tool to solve this kind of problem here. Okay? Now, if I want to split up this denominator here, all I have to do is just figure out, like, okay, how much of a and b is here? I do this out, this algebra, which is a little bit long, but it makes sense. And then I figure, okay, a plus b has to equal that amount of x. Negative 4a minus b has to be that amount of constant. Alright, so what about a more complicated situation? What about if we were doing a guy with more than two things under the denominator? How would that look? So let's say I wanted to integrate x squared minus 2x plus 10. Yeah, that's a good one. And then I'll do x over x minus 1 and then x minus 2. Okay, so I have three different guys under there. Okay, how would this look? Well, it's going to be the same exact thing, okay? As in, this guy right here, he's going to look roughly, I probably am switching it up a little bit, but this guy right here, right, he's a asymptote at x, at 1, at 2, so he's probably looking more or less like this. Asymptote at 1, asymptote at 2, I forgot an asymptote, sorry about that. So here's 0, here's 1, here's 2, another asymptote there, asymptote there. And you guys can see that, hey, this is the same thing as if I add up a 1 over x, a 1 over x, if I did a 1 over x minus 1, and a 1 over x minus 2. Okay? That in some way, this guy here is some addition of this and this and this. Okay? Again, this is not quite the graph. Maybe this guy's flipped or something like that, but it's basically the same situation. Okay? Alright, so what do I do to solve this? It's going to be, given this insight that this is really just a sum of these guys, I'll just do what I did over here. I know the ingredients of this guy, I just don't know how much of each ingredient. So let's try to set this up. Do it over here. So let's show this. I have x squared minus 2x plus 10 is equal to x, x minus 1, x minus 2. Alright, so let's now turn this, let's break it up into its ingredients. A, x, plus b, x minus 1, plus c, x minus 2. Okay? Alright, so what happens with these guys? Again, we just get the same common denominator, alright? This right here is going to get what it's lacking, which is going to, so we're going to get the same common denominator over everything. Let me say that first. And this part is going to get x minus 1 and x minus 2. So it's going to get a x squared minus 3x, and then, so it's x minus, let me write this out without skipping so many steps, because that's just going to confuse people. X minus 1, x minus 2. Then I'm going to do b of x times x minus 2, right, because it's lacking the x and the x minus 2. And then we have a c, who is going to be x times x minus 1. Okay, so let's now simplify this, or multiply this out. Let's do some distributions here. I'm going to have a times x squared minus 3x minus, or plus 3. I have a b times x squared minus 2x. I'm going to have a c, which is going to be x squared minus x, with the same denominator, as we know. And so where do we go from here? Let's now get all of the x squared terms together, all of the x terms together, and all of the constant terms together. In this case, there's only one constant term. So, all right. So how much x squared do we have? We have a, and then we have a b, and then we have a plus c. All right. How much of the x's do we have? This is going to be, we're going to have 3a, oh yes, negative 3a, excuse me. We're going to have minus 2b, and we're going to have minus c. And how much constant do we have? Well, this is the only one with a constant. There's 0 constants here, 0 constants there. So we get a. And if you just sort of, just to emphasize this fact, there's sort of one constant here, then x there, there's an x squared there. Alright? So, now we see, okay, if these are the ingredients of him, then what we should do is set, we have 1 x squared here, so let's set a plus b plus c equal to 1. A plus b plus c is equal to 1. We have negative 2 of x. So so how much x do we have? Negative 2. So let's set that equal to that. And then how many constants do I have? I have 10. So that a is equal to 10. Okay, now let's solve this system of equations. Let's figure out how much of a and b and c this set of equations forces us to have. So alright, a is already solved here. That's great. Let's plug that back into there. So this is going to be now 1 is equal to 10 plus b plus c, which I can rewrite as negative 9 equals b plus c. And this here turns into, this is going to be negative 30, rather big number, which I can then rewrite as, so let's get those two equations next to each other. Negative 9 equals b plus c. This turns into 28. Yes, 28 equals negative 2b minus c. All right. Now let's let's try to reduce this. Let's see. I have a positive c here, a negative c there. Let's just add one of this equation onto there. So let's add negative 9 onto 28, which will give me 19. Let's add b plus c onto negative 2b minus c. So this turns into negative b plus 0. So congratulations, b equals 19. And now I can use this equation on there to get negative 9 equals 19 plus c. C, therefore, is equal to negative 28. Right? Yes. Okay. And just to make sure, so our final answer here for this summing of things is A equals 10, B equals, where'd that B go? 19, and C is equal to negative 28. And if you want to make sure that all makes sense, look at the original set of equations and plug it back in. So yeah, A is equal to 10, no work there. And if I plug in these guys into there, so if I add them all together, 10 plus 19 is equal to 29. 29 plus negative 28 equals 1. I'm not going to bother with that. You guys can try that at home. Okay, so this is the right amount. And if I want to now integrate this guy right here, all I have to do is now integrate basically this right here, which is again just a nice set of constants. So the payoff here, I guess I'll write it, I want the rest of this space, so I'm going to do it in this weird spot. So if I want to integrate x squared minus 2x plus 10 over x minus 1, x minus 2, then all I have to do is just integrate, let's see, I have a of this, so integral of 1 over 10. How many of that do I have? I have 10 of them. Okay. Oh, excuse me, that's 1 over 10, that's x. Then I have, how many b's do I have? I have 19. Integral of 1 over x minus 1 dx. And how many c's do I have? I have negative 28 of those. So then, plus negative 28 of the integral of 1 over x minus 2 dx. Okay. And this is natural log of x, this is natural log of x minus 1, this is natural log of x minus 2. And that's fantastic. We now have the solution, okay? As in this is the, doing a little more work with this, gives us the integral of that. Okay, so this is a really powerful technique. This is a technique, and it's very simple to understand. The basic idea is that, hey, a guy like this, with all of these polynomials underneath, these different roots of x and x minus 1, x minus 2. It looks like this with these different asymptotes, and it seems pretty clear to anyone looking that, oh, yeah, these asymptotes are just some kind of combination of these other functions here. This guy is in some way a sum of this and that and that. And the trick is, all right, let's turn this into that. Let's do a lot of algebra to finally figure out what those a and b have to be. And namely, the big trick is to realize, okay, if I have this much x squared, that means a plus b plus c has to equal that 1. That negative 3a minus 2b minus c has to equal this negative 2. That a has to equal 10. That's the trick to finding it. And why do we care about all of that? Because it allows us to turn this integral into something that's doable, into something much more familiar. You know, it basically is one of those great mathematical tricks of turning a difficult problem, an impossible problem, into one that is simple and straightforward by comparison. Okay, we'll talk about a more complicated situation in the next video.